Excellent. So for the last of the details we'll be looking at today, we're working through with this week, is going to be our veranda detail. So you've been given a lot to work through this week. Look, if you're not getting it done all in this week, that's fine. But I would give everybody that information to get ahead as much as you wish or are able. So the other section we've got to do is, or other portion we've got to do is a section through our veranda, and to show how that veranda is included. What I was speaking about previously is with your veranda, you can choose essentially where to be pitching, at what height to be pitching your veranda from, as long as it's minimum 2100 millimeters to the underside of that entry point there to your veranda. Then, but the reason you would choose exactly where to be pitching it from is because of your sheeting. So you want to be looking at your sheeting, and then understanding how much that's going to be overlapping on your slab, and then interpolating back to finding out where you're going to be running your pitching beam, because what we don't want to be doing is chopping boards off halfway through and having our pitching beam sitting at a half chopped board. It just looks like a terrible detail. Whereas if we do this, well, then that veranda can go all the way along that edge, and we're essentially taking out a weatherboard there for our pitching beam goes in. So through your design, naturally, that's one of the things you would do if you were designing this in real life. You're not required to be doing that for this project because you're just doing a section through. But what I will want to see is that we're starting with a full board underneath that pitching beam. Beyond that, what we're dealing with is we're mounting this veranda off of that front face of the house. A couple of ways of going about it. One is to carry your rafters inside and be mounting those, and then you're doing some flashing work, etc., around your rafters. Or the neater detail, I think, is to have that pitching beam sitting within your cladding. That pitching beam could be brought up to the height to support your sheeting and have your flashing coming directly over top of your sheeting from behind your weatherboard there. So because you're going to have rain coming down on here, you're going to want to ensure that no water comes up there and then goes into your house. So typically you'll have sarking on underneath your weatherboards there as well, but you'll have to have a flashing that carries up inside your wall and then comes down onto your roof sheeting. And I think to have that flashing scribed in your roof sheeting is also another good detail. You might want to put that on your note, say flashing scribed into flutes of sheeting. Either way, your sheeting at this end is the bottom pans of those are going to be turned up to stop that wind-blown moisture. But for our bushfire compliance as well, because we can't have gaps larger than 3 millimeters, we want to scribe that in. But it's a good detail for weather resistance anyhow. But that's a detail that you see when you're looking at it from this direction, not as a cross section. So it's something that has to be included as a note. So you have your roof sheeting. Your roof sheeting is going to be a depth of 13 millimeters. Oh no, sorry, 16 millimeters for standard custom wall. So 16 millimeter deep sheeting. So 16 millimeters between this line and this line. Your sheeting will also typically span 1200 millimeters for an internal span or an end span. So from this span here, from both of these are actually end spans. So those end spans will typically be 900 millimeters. So that information you're going to get from your product manufacturer. Yeah, with this veranda, you're really quite safe if you're putting one batten internally. So we don't need to refer back to our manufacturer specifications for this material, because if we include that one batten internally, then we have very short spans for our sheeting. We're talking, it's a bit over a metre, the width of our veranda, so it's quite a small veranda. But if we were designing a different type of veranda, we would bring up our design guide from whatever company, whether it's Lysart or Fielders or Revolution or so, and see for the depth of sheeting what our internal and our end spans for that sheeting are going to be. Those internal end spans differ depending on the sheet thickness. So for 0.38 sheeting, you've got much smaller spans, and 0.42 sheeting or 0.48 sheeting, you can have larger spans. Sometimes you might choose to have 0.48 base metal thickness sheeting just to achieve a certain span thereafter, but typically you're going to be specifying 0.42. Unless, of course, it's a bullnose veranda. Like bullnose is where it comes along and it curves down, or a concave veranda where it starts high and then curves in. Then, for that type of veranda, you use a different type of steel, which is custom blue ore, and that comes in a 0.6 mil thick sheet, which will get a different span once again. Anyhow, for this, we're probably going to be dealing with 0.42 sheeting, and our span is not an issue as long as we've got an internal batten. So we've got our pitching plate here, and then that's going to also be pitching our sheeting. We might have a batten at the end or mount it off our fascia, depends, and I'll talk about that in a minute, but we'll definitely have an internal support here. So a batten running internally. With our fascia here, because we've got a metal fascia to the rest of our dwelling, we might want to have a metal fascia to this veranda as well, to match in with those things. The drawback of that metal fascia is we'll have to have an end to it. They're not quite as neat. You might prefer to have a timber fascia.
But you need to use the right timber because of the bushfires.
No, not because of the bushfires. But you have to use the right timber, and I'll talk about that in a sec. Or you might want to go metal fascia for the rest of the building, and then timber fascia for your veranda being a distinct element. I'm happy with either approach, whether you specify metal or timber fascia. But if it's a metal fascia, well then you're going to have a batten in here to take that weight for your sheeting to carry 50 millimetres over into your gutter. If it's a timber fascia, well then we can set that timber fascia into these posts. So notch that into the post, and that can carry up, and we can do away with this batten because we can have a structural fascia. So like a 180 by 32 mil fascia. But that fascia, the timber that fascia is going to have to be, or the timber we're going to have to specify for that is F7 H3 LOSP. So it's written here on our 80 by 88 by 88 post. So F7 H3 LOSP. If it's a timber fascia, we'd also need that for our fascia as well.
When you say notch it in, you mean literally notch it into the post?
Notch it into the post, and then fix your rafters to the back of that fascia. What there is in this detail to include a metal fascia is that there's a veranda beam here, and then that veranda beam is notched into the post, and then the metal fascia is on the outside of that to create that continuity. One way I would improve this detail is actually rather than have the rafter in the front in our view, have the post in front in our view, so we can see the interaction between the post and the veranda beam. The best detail, which is probably what is happening here, is that that veranda beam is notched into that post halfway. So that post is notched out and the veranda beam slots into that. Basically, it would almost sit there without even any fixing because it's seated into our post. So can visualize that. So notching it into the post there like that, yeah, it means you're not typically harbouring as much moisture behind there and having that face fixing and relying on fixings through that will over time weather this notching out your post and sitting your beam on there.
So quite literally, you would take out that take out that beam, notch the timber into the post, and then run those beam whatever.
So rafters.
Run the rafters straight to the notched fascia.
No, I think what I would do is I'd have the posts come up.
Yeah.
So the posts are coming up, and then I notch the 30 millimeters out of those posts.
Right.
And then I set that veranda beam into that notch in the post, but I carry the back of that post all the way back up the back of that veranda beam, and then I run the rafters to the back of the veranda beam, and then fix through the veranda beam with two bugle batten screws. To creates a very solid, rigid connection there that's not going to fail, even as it gets older and gets more weathered. Which it should have a lot of longevity, being H3 LOSP. Now that H3 LOSP, what that is, so F7, everybody knows about timber strength. So you've got the MGPs, etc., but then you also got your F grading for stuff that doesn't have machine graded pine, because MGP is just simply for machine graded pine. So typically all of your LOSP timbers come in an F7. So that's that strength grading for that timber. The H3 treating, so H3 is about your hazard class. So hazard class 1 and 2 are for protected indoors. So hazard class 1 is just your standard pine, untreated pine. H2 is your termite treated pine. H3 is for anything outside exposed to weather. And then H4 is in ground, I think, and H5 is in ground wet. So all of your timbers that are going to be exposed to weather, you use H3 LOSP. What you don't do though is use LOSP inside a house, because that light organic solvent protected timber does off gas. So it's not something that you want to use inside a building. But it certainly has a longevity outside. Then beyond that, I'm happy with you, and your selection of your size of timber is going to come from your selection of your rafters. Well, yeah. I'm happy with you specifying the 120 by 35 F7H3 or 120 by 35 rafters. Now they don't have to be H3 treated. These ones are protected. They're under cover. But what you might want to do is use dressed all round. So that means your timber, which has been smoothed off quite nicely all round, so that when it gets painted, it looks it looks nicer. It doesn't look like a rough, cheap job. You can you can see a cheap house from an expensive house by those smaller details. So because we're doing such a small veranda, it's a very small amount of money for dressed all round. So you might want to go 120 by 35 MGP 10 DAR, dressed all round, for example. These ones don't have to be LOSP, but if you do LOSP, they're typically dressed all round anyhow. and primed, ready for painting. I'm happy with both. So you can work through your timber span tables and determine the size of your rafters if you wish, or just use your 120/35. So I think you can actually get away with 90/45s for that. But yeah.
120/35 is more elegant.
Yeah. And so we've got 120/35 rafters, and then that means you've got to have a 120/45 veranda beam there. Or if you're having a fascia, then it's going to be a taller fascia. It's going to be 180 to match the height of your battens as well. Then at 1200 centres, your 45/90 MGP10 battens will suffice. The reason we write them as 45/90, not 90/45, is 90/45 is when it's standing on edge. 45/90 is when it's sitting on flat. Then your standard post width is going to be 88/88. Once again, with this, if you were to work through your timber span tables, I think you can get away with a smaller post. But 88/88 is what's going to be available at the timber supplier. So there's no point in specifying something smaller. And what you can do is you can get a timber supplier table. We've got so from Softwoods. So get that table from Softwoods that shows all your supplied sizes. But yeah, take it from me that your post is going to be 88/88. You're not going to get a smaller one easily. Then the other detail is your pitching beam here, and from working through that with your 120s and then the size of your fascia and then the height of your battens, you're going to arrive at the height of a piece of timber. Now, that's probably going to be an odd number, like 173 or something like that. You don't buy a 173 piece of timber. What you do is you buy a 190 and you cut it down, or you buy a 180 LOSP and you cut it down. So you'll get this and you do a sloping top cut to the top of that with a circus saw to cut that down to exactly the right size. So we've got 180/31 F7 H3 LOSP cut down to suit. Then once again with that detail, two number 17 bugle batten screws from your pitching plate into your framing. Not sure if you can do it with nails, but the bugle batten screws can be tensioned up and hold it nice and firm and nice and rigid, and that's and then with your rafters. So once again, your bugle batten screws in from the ends, and that detail of fixing your bugle battens in through the timber into the ends enables you to straighten up any of your timber, because hopefully you get all lovely straight pieces, but sometimes you don't. And so what you do is you get a clamp on there and you bend it around a little bit and fire in a bugle batten from the end to straighten everything up as it's going in. So it not only stiffens the whole structure nicely, but it enables you to straighten everything as you build. So that's the top bit of the veranda. So, in regards to the bushfire compliance, you don't have to have bushfire resisting timbers when you're up above 400 millimetres.
Okay.
And what you can do when you're down at ground level, you can have, so in that private certifier's summary says you can have your standard timber as long as it's protected in a post stirrup where the bottom 75 millimetres is picked up off the ground, which no coincidence about it, is also exactly what you have to do for termites. So handy that. So our posts, because we're going into a concrete slab down below, and that concrete slab will be setting that concrete slab down 50 millimetres below our house level, just in case anybody was to wonder about that. So we create a set down for our external veranda slab. That's so we don't get, if we get rain coming into that veranda slab that doesn't want to enter the house. So we have that set down.
Would you be putting a gradient on that? Because the thing is, like, you know, 2% gradient, and you're never going to get water in the house. It's not going to make any difference.
Yes. Yeah, it's good to have a 1 in 100 slope on those. Technically, you don't have to because this one's protected by a veranda. But yeah, it's good to have a 1 in 100 slope on any exposed slab. But what you're going to do is you're going to have your step up to your house, so you have your set down. Because that's going to be your best protection. Even if you have a 1 in 100 slope, and then you get some really strong winds from, what is it, the east, northeasterly or so, then that's going to,
the other thing about
you're going to rely on your set down.
But that's the other thing about your set down of your 75 mil step down, or 50 mil step down, is now you've got tiling, you've got all timber or whatever you want to put in it, if you want to put a surface on it. Do you want to step down longer if you're going to put a surface on it?
Yes.
Yeah.
Yeah. So what you're going to have to do for the base of your veranda is secure your posts to your concrete slab. Does two things. One is it provides resistance to uplift for that veranda. So as we get wind under there, we'll want to lift that veranda. So we get tie down, but then we also get the securing of the base of our veranda in terms of like not triangulation, but in terms of bracing the whole structure. So the simple, and because of our bushfire compliance, we have to have all of our posts in a stirrup. Either that or they're bushfire resisting timbers and termite resistant timbers. It's going to be much easier to get just your standard H3 LOSP. So set that into, look, whilst being product agnostic, it's going to be super easy if you get the product catalogue and select a PSFS 90 that's 300 deep. So your 90 mil post shoe with a 300 foot on it that's cast, that's embed minimum 100 millimetres into the concrete slab, leaving minimum 75 millimetres upstand, and then it says bolt as per manufacturer's specification. Pretty sure in the catalogue it specifies 2 M10 coach screws. So quickly have a look. Actually, for our product catalogue, I'm pretty sure there's one of those in product information. So yeah, project one specific post anchor guide, and then external cladding for prime line. Probably would be good, yeah. So the things I had to add were, that's right, some more engineering details. So I'll do some snips of that stuff for extra stuff if you want. And then another, probably an interesting one for you to have would probably be just a timber sizes available chart in SA from Softwoods or something like that. So that, I'll add that one in there now. So you can specify your sizes of timber for your veranda, for your fascia, and things like that if you're using timber fascia. Is that all quite simple, straightforward for producing your details? Any questions about that?
Was you said you mentioned the stirrup? Is that the?
So that's the So that's the yes. So that's the post shoe. So
Yeah.
that's these things. So there's a whole host of different connectors. Now, if you want, you don't have to use this type. You can use one of these if you want. To hide it, what you do is you drill a hole in the bottom of your post, slot it on there, and then fix with your coach screws down underneath. Or you can use these cyclones stirrups if you want. But yeah, that's your normal standard post shoe.
But in the detail you showed us, it was actually set into the
concrete. So these ones are dynabolted.
Yeah.
Yeah, that makes work on site simpler if it's dynabolted later on, and you can dynabolt them to the top. Use a shorter post stirrup and dynabolt them to the top.
It doesn't look as clean though.
Yeah, it doesn't. That's right. It doesn't look as clean, but also you don't get the same degree of tie down. It's not as rigid and strong as if they're cast in place.
Yeah.
So it's Look.
But also if it's this little, what is it called again? Stirrup.
Stirrup. Yeah.
Yeah, small stirrup. It's going to be holding a beam at such a height. Like that has to be ultra level, because as the post gets higher, if it's a little bit off, it gets more and more.
Oh,
Or is it normally?
you got a little bit of free play in here.
Okay.
Yeah. It's not too hard to get them back.
I guess because it's the two, you can skew them around as you need.
Oh, these two, yes, that you can do as well. Yeah. But no, but it's not too hard to get them bang on, because you can set string on this. Have them there. But yeah, you got two options. Yeah, one is to cast them into slab, or if you want to draw them as dynabolts, that's fine as well. One issue though with dynabolts is your edge distance. So typically, with a lot of your dynabolts, with your M10 dynabolts, you need to have at least 80 millimeters edge distance from where that dynabolt goes into the edge of your slab. Because if you don't have that edge distance, then you tighten up the dynabolt, it can pop the concrete off. Because there's a lot of, as that expands inside there's a lot of force inside that, and concrete doesn't have very good tensile force. So force and tension. So you can, So you'll probably want to have those set off the edge of your slab a little bit.
And what if you go through the mesh as well?
Yeah, you might. Yeah. It's not a common thing that because you've got 9mm mesh at 200 centers. Your chances of hitting that, and your masonry bit will go like this, and then yeah. But either way, that the detail of casting them in was typically what I was asked to draw in the engineering office, with minimum 100 casting.
And that PSFS9 is just the type.
That's just the type. So as we
9mm.
Exactly. So that's for a 90mm post, and we're using 88 by 88. Hence your 2mm bit of free play there for you.
Yeah, I see.
Yeah. And then, so there you go. That's your PSFS full stirrup 90.
Yep.
And what does it say for our, two M10 bolts for, uplift capacities for very, very different joint groups. A joint group for MGP 10 a week JD5. People remember? Did you go through that?
No, not really.
Yeah, I think JD5, joint group 5 for F7 pine. So JD5, that'll give you 12 kilonewtons of restraint per post. Yeah, I don't think you're going to have any forces anywhere near approximating that.
Yeah.
So yeah, 210 bolts. Or you can go with 50 by 10 millimeter coach screws. All right, well, I'll stop that recording unless there's any more questions about that.